And we're on. So, welcome to the first official MNB Networks Network Design Fundamentals. I couldn't think of a really interesting name, so that's as good as it gets, I'm afraid. The kind of, as mentioned in the lead up to the session and before the session, it's really just about, it's for fun, it's to add some value to the community, hopefully, give something back, help people with if they want to get into network design. Um, Obviously, it's a massive area, and now when I first started working in networking, it was mainly around routing and switching. So, for example, the CCNA was just called the CCNA. It wasn't called CCNA routing and switching, but that's what it was, and they filled the gaps with things like electromagnetic interference and protons, neutrons, and electrons, and attenuation and things like that. So there was a whole, it was like a physics module. But and the reason that I'm sort of saying that is because you fast forward like 15, 20 years, and now the CCNA has I'm not totally up to speed with all like the certification rejigging, but the CCNA has a dedicated CCNA routing and switching. I think it's changed again now. But even to pass the composite CCNA exam, you would need to have a back or an understanding anyway in an understanding in I've had the wrong monitor on there, so let me just that's better. So so yeah, the CCNA is like LAN, wireless, WAN, and even though it's an introductory certification, there's a whole load of stuff that you need to pass now. So where that goes to now is when you have to learn how to implement all this stuff in silos, but they're all dependent on each other, and then you start moving into network design. You know, I've come from the perspective where I had pretty much implemented everything that I was designing when I'd moved into network design. So that kind of benefited me, and we'll maybe do other sessions if people are interested on career path type stuff. We can do that at a later date. So this is more just an introduction to network design to explain, you know, after like quite a bit of time in the industry, how the design process works, what you can expect if you want to move into network design as a career, and then give some examples of what it really looks like. So, without further ado, I'll just sort of move into the short presentation, and then we'll start whiteboarding some stuff. So, if there's any problems with the stream or anything, folks, just flag it up in the chat. So the design process, right? If I'm a network designer, and we never ever just design a network for the sake of it. The reason that a network is going to be designed is driven by you probably hear this all the time. Let me see if I can increase that. Sorry. Hopefully that's a little bit better. Any better on the sound? Brilliant. Just had to tweak a setting. Sorry, I'm just using this OBS software. It's the first time I've really used it, so just keep me honest if there's any issues. So the design process, you never just design a network because the software defined whatever has come out. It's always driven by business requirements, and a business basically pays your wages, but it's not. They don't employ you. They don't employ you just to do IT. Well, obviously they do. Thanks for the feedback. They don't just employ you thinking, oh, I want to hire a network person. What they do is they have like the business, business stakeholders have objectives. So if you're a soft drinks company, you want to either sell more soft drinks, produce more soft drinks, in a faster period of time, which is being maybe it's a new product that started off with producing small quantities, and then it's really taken off, and the business are saying to you, we need to be able to handle this demand. So that will filter down to somebody like an IT director, and the IT director will take it to their team. Or I'm just using examples here. It might be a network manager, an IT manager, whatever. But typically somebody who interfaces with the business, which is normally an IT director. The IT director will take the business requirements and then take them to their team. That might be an in-house IT team. It might be a partner, like a network integrator, an internet service provider, depending on what it is, and say, look, we are in this position, we want to expand, or we want to expand into a new region. How do we do that? So that always remember that when you're creating a network design, yeah, it's cool, it's good to play with cool stuff, but don't get distracted by the fact that the reason that you're actually doing a network design in the first place is being driven by your employer to execute their business, which they earn their bread and butter, and as a result pay you. Gathering the requirements has got so many different parts to it, and we'll touch on some of it. I'll focus on it more from like a network design perspective rather than the business design, because it's a bit more interesting for this introduction session. So after you gather the requirements, you have conversations with the business or whatever, or whoever is the stakeholder, and then you'll start working on a conceptual. These are just some names, but it's a conceptual design, but it's typically referred to as a solution design or a high-level design. And what this part of the process is, where you define, let's say you've got 100 sites that you need to upgrade the LAN or upgrade the WAN, then the high-level design and the solution design is a high-level overview of how things are going to operate. So let's say there's 100 sites and we split them 25 large sites, 50 medium sites, and 25 small sites, and that might be based on like user numbers, or it might just be, for example, in retail, small sites might just be a store that all they need is a small store that all they need is like point of sale stuff or whatever, and connectivity to the payment card company, and there's not much else that happens at the store. So that's quite a vague explanation. So what you would do then in the high level solution design, another way that this could look is like if you had like a large network, right, and you could say, well, this part of the network we can run on IPsec over the internet, this part of the network has to be like MPLS, and this part of the network, all of the sites are in a small metropolitan area, so they're all close to each other, so they could potentially be connected with VPLS, or which is a layer 2 Metro Ethernet solution. We'll touch on that slightly. If you're not familiar with any of the terms, just flag up in the chat and I'll try to explain them as I go through. So then what you might say in that scenario is say, okay, all of the IPsec sites, all 25 of the IPsec sites, this is how they're going to look at a high level. All of the MPLS sites, this is how they're going to look at a high level, and there might be multiple iterations in each of those. So we'll get onto some diagrams and drawing in a minute, but that hopefully explains like high level design. So the business requirements feed into the high level design, and then the high level design, once that's agreed conceptually with the business stakeholders, the technical people, sometimes the end customers and users who are actually going to be nothing to do with IT. Sometimes it's like the business users. So if you're in the retail store and you wouldn't talk technical to them, but you might say, look, this is how your system's going to operate, does this meet your requirements? And they might say yes or no. but there's normally multiple people who give sign off to make sure that the business requirements are being met by the high level design. And then we move into the low level design, or the detailed design. I probably should have put low level here, and that's where we start talking about bits and bytes at the real technical level. So that's where we get into stuff like, right, port gig 101 is going to connect to, on switch 1 is going to connect to gig 101 on switch 2, or gig 101 is going to be the uplink to the WAN router, and the WAN router always uses interface 1 and then on line card 1, and then if it's a port channel, if you want redundant handover. So it's all these details, mainly layer 1 to 3. So layer 1 being physical, so that could also include things like do you connect the devices via fiber or copper, which ports you connect to, and various different things like that. And the reason that you need to put a bit of time into that is because you can just say, right, well, we'll just connect via fiber, but then there's multi-mode fiber, there's single mode fiber, there's different grades of fiber that support 1 gig, 10 gig, long range transceivers, short range transceivers. And this is all, this is most of the equipment has already been specified. I missed that out, but in the high level design, you normally have a bill of materials defined as well. So that's why, they are if you think about the design process, it comes business requirements. If you look from top to bottom, you gather the requirements, you do the high level design, and then you do the low level design. But actually, certainly how my career panned out, when you're learning how to design networks, it actually goes in the opposite direction. So you would learn how to configure stuff, and probably not be doing design initially, or troubleshoot stuff. And then you would start getting into saying, right, the best practice is to always connect the ports, the uplink ports on switch 1 and 4 in a stack, if it's a 4-switch stack. And I always want to use 101 for the first link and switch 401 in the second link. So you actually learn configuration, because you have to learn the commands before you can actually design stuff at a low level. Then you start getting into detailed design. So again, this is working how I worked up in my career. Then I started moving into writing detailed design documents, and that typically gets signed off by this the person who writes there's normally a design authority who wrote the high level design, may or may not review your low level design. So it comes, I don't mean this in a condescending way, but just in the context of this slide, the process comes top to bottom. So gathering the requirements, solution design and detail design, but then it kind of comes back up the chain where the project engineer doing the low level design and the implementation might or might not, that you might get someone doing both of these roles, but it comes back up and then it gets signed off before it then goes back to the customer, whether that's an internal customer or an external customer. So that really hopefully explains the design process, where you would go from gathering the requirements to developing a detailed design. And once you get a detailed design, maybe 90% complete or 80% complete, depending on the project, that's when you would actually start implementing the project. So you would have configuration templates on how to deploy different parts of the network, but you might have details missing. So for example, you might have subnets allocated for, let's say, the DMZ, or you might have a public subnet allocated from a service provider for a DMZ. But until you get further into the project and you're actually putting the web facing servers on on the internet facing, you might not like allocate those IP addresses until then. So that's why when you get to a certain stage, you'll never be able to write a detailed design which is complete um, in one shot. It's just impossible, because the other thing that you have to be aware of when you're deploying projects is that when you're working for an end customer, whether it's internal or external, there's change control. So the customer might have a new business requirement that they might have a new business requirement that comes in that you need to accommodate for in the design. So I think that kind of wraps up the design process, and I've got some other stuff that I can move into actually talking through how some of that works. But before I move on, does anybody have any questions or feedback on that before we move on? Even if it's rubbish, just say. Cool. Alright, so just talking about application requirements then. So let me see if I can mark this up. Pen. Cool. Right, so applications used, right? What do I mean by this, right? So I mentioned that there's basically you have to gather requirements, and that could be business requirements. The business requirements also drive like the application requirements in any IT infrastructure, not just network design. So that might be like a customer service or a CRM, customer relation management service. That might be on site. Back in the day when I started out, most stuff was the cloud didn't really exist, and everything was normally located in a company's office or HQ somewhere, that or something like that, or the odd company might have a data center or whatever, but the applications were normally hosted on-prem. But nowadays, obviously, there's a lot of most applications have an option to take cloud-based services. Now, cloud-based services could be, a web-based CRM like Salesforce.com, where you just go to salesforce.com and log in, and the company might have a bespoke version of it, or they might just take an off-the-shelf version. Or it could be infrastructure as a service, hosted in Amazon Web Services, Azure, Google cloud platform, or it could still be in a co-location data center, like so a hosted data center. And the reason that, or some of the reasons that you might have that is people think like, oh, the cloud is here, so everything will be going to the cloud, but it's not quite as easy as that. So there's things that we need to think about from a compliance perspective, like certain countries in the world, the traffic is not allowed to leave that country, and in particular for the internet is an application. So certain countries like China, Turkey, these are just ones off the top of my head. If you, for example, were using a cloud-based firewall or proxy service, then in order for that to be a compliant cloud solution, then there would have to be an instance of not only the cloud service, like the firewall or whatever, but then the internet service provider would also have to break out to the internet from that a Turkish or a Chinese based IP. And it's not picking on those two countries, it's just two that are spring to mind because I've worked on those types of designs recently. So it's understanding, the traffic flows, whether you have to go to, there might actually be applications on a local site, like legacy applications, payroll stuff, HR systems, and then you think about like mergers and acquisitions. A global company's strategy might be everything in the cloud or everything in a data center. However, if they've bought 10 companies last year, then if they bought 10 companies last year and there's a load of bespoke applications. There's going to be a time where you can't just buy the company, put them on the network, and then get rid of the application. That might happen longer term, but you have to accommodate for like different applications in different places, and that kind of leads into traffic flows. Yeah, that worked. So probably don't need to say too much about that because I covered that in the last point. But traffic flows are basically where's the traffic going, and I've got a good diagram to show you about that in a minute, so that'll be explained better there. Special site requirements, you might have, I don't know, something like you might have a multi-tenanted site. Your company might have strict segmentation requirements between different parts of the business that go past like separate VLANs. You might need to put them in different VRFs. You might need, and if you do that on the LAN, you need to think about how that propagates into the WAN. There might be like a manufacturing floor at the site, which is a whole different ballgame on its own, and there's a lot of considerations there also. And then in respect to like WAN, you're talking about bandwidth again as an internet based service. Okay, you've even got clients now, things like iPads and tablets and things like that, which are VPN clients that VPN, they might be on a site, but let's say in an agriculture organisation or something that's field based, but let's say agriculture, and you've got a farmer who's out in their field and they're doing whatever they do on an iPad, and there's no Wi-Fi in the middle of a field, right? So like what might have previously happened is you might have a couple of different things. You might have a VPN client, a traditional VPN client on the tablet that connects them back to head office. But if they lose their LTE signal or 4G signal, 5G signal, whatever, and they're in the middle of doing something and then have to disconnect and then reconnect, that might not be optimal. It might be no problem, or they might get used to it. But for example, there's other technologies, VPN technologies that you might want to think about, which are there's a product called NetMotion, and I'm not any kind of advocate for it. NetMotion is, again, it's just one that I've used in the background, and what it basically does is that scenario where you're walking about the field, you might have like the tablet connecting and disconnecting and reconnecting, but it doesn't lose any packets because the VPN client smooths it out. So that you probably thought before, oh, networks are routers, switches, and firewalls, but it's going closer and closer out to the endpoint, and more is coming within the remit. So the WAN connectivity is like there's so many different ways to connect to the WAN, which is also covered by the traffic flow diagram. So security, obviously, that's inherent in everything now, and it used to be a firewall at the perimeter, which was black magic, and I won't tell you the detail, but when I first started out in my IT help desk job, one of the things that I used to have to do was when, let's say, dodgy emails got sent into, like, across the organisation or into in and out the organisation, they would get basically quarantined by an email proxy server. Flying CCIE, yep, it's getting recorded, and it's getting recorded local, and it'll be an MP4 from my laptop, but I've got it open on a stream next to me and it's looking alright, so let me know if anybody else is having problems. But yeah, it is getting recorded and it'll get uploaded to YouTube. So, where was I? Yeah, alright, cool, thanks for the feedback. So yeah, I mean, yeah, I'll not go into that story too much, but basically it used to be a manual process where you had you had a firewall at the edge, email coming in and out of the company, but I would be sitting on the IT help desk, and then what would happen if I sent one of you guys an email and it got caught, and it got, or one of you sent me an email, let's make you the dodgy guys, and like it came through to me, the IT help desk person would go and basically look at the email contents and what was flagged up, and then right click and then release it. But that would only be after the person said I was meant to be receiving an email, because genuine. But that was the process back then. You can imagine now the amount of attacks that we had if we had to do things manually like that. It wouldn't work these days. So there's layer 7 firewalls. That thing that I described about the tablet and the endpoint being potentially using 4G LTE and going directly into the network from the device instead of over secure Wi-Fi, that effectively moves another point of entry of the network down to an iPad, right? So that's where, like, when we talk about like BYOD and all that, it's a bit of a contentious subject with some, and that's why we have things like mobile device management, in order to make sure that things that are coming onto the network are in line with policy. And routing is just like, you might have some specific routing requirements. So let's say you've got a legacy link to somewhere else. You've got two WAN links, which are your primary links, and you've got a backdoor link to a supplier. I'm not saying that that's a good practice, but it happens all the time, and I see it all the time. So those are the sorts of things. If you like, you're going to a customer engagement, whether it's internal or external, those are the types of things that you really want to be talking about when you're gathering the requirements. So any questions on that? That's the design process part finished. Is there any questions before we move on? Good stuff. Right. Let me get rid of this pen, if I can work it out. Erase a link, and then out of there. Right, so let's move on to the next one then. So what we're going to move on to now then is, I'm going to show you some high level designs. So got a couple of questions in just before we move on. So how much time the phase of gathering requirements could take? It really honestly does depend on the project and how helpful the customer is, how much information is available. So for example, the types of stuff that you're going to have to gather for requirements are, existing network diagrams, existing configurations. Sometimes there can be pushback on that, especially if you're going in as a network integrator. So I've been working in the network integrator space for about 12 years, and to be fair, like most people, they engage you because you're a trusted partner. But sometimes, like, there might be something in the security policy that says they can't send you configurations, so you might have to view things on the screen whilst they're showing you them, for example. And obviously that takes time, because you have to set up a WebEx or go to the site and see them or whatever. But like, if I was to throw a couple of examples, right? Let's say most stuff can be collected remotely or via WebEx, especially these days, now that people are WebEx or your preferred platform. But you get the picture. Most of it can be done remotely. I'd say, like, for a small project, you're probably looking at like, I don't know, 40 to 50 days consultancy, right, where let's just take a firewall install. I would suggest that a firewall, and I'm just making these numbers up, right, a firewall refresh, for example, might be, depending on how complex it is and what tools you've got available, it might be like 10 days design, and within that 10 days you might have like 2 or 3 days requirements gathering, and then 7 or 8 days to write a design. But that's just like that I'm talking about there, like if you had like a firewall pair, like so 2 firewalls like being configured as a cluster, and then you move in like, I don't know, 15-20 days implementation, and detail, well, yeah, implementation, planning, cutovers, and then up, like what I said about, like, you know, you would get the detailed design to a certain stage. Yeah, you get the detailed design to a certain stage, 80 to 85%. So even though you're implementing and building, so you maybe build the project in a lab first, do some testing, then get it racked and cabled at the customer site if they've got space, and power and cooling and all that available. But whilst you're doing that testing and getting things on site, you also need to be updating the documentation. So that, in that case that I'm talking about, a firewall, that's you filling in the outstanding 20% of the 80% complete. So it's like you're continuously gathering requirements, because you might get into the project, even though you're into the pre-build or the project implementation phase, you've still got to get information from the customer, such as how many IPsec VPNs have you got? Do they go to internal internal sites? Are they part of your WAN, or are they IPsec VPNs that go to a third party supplier to provide you a managed service? So it's like there's going to be an amount of time for initial requirements gathering for the solution design, and then more time for initial requirements gathering and writing the 80% of that low level design. But then once the project really starts moving, you're continuously, and that's why it's so important to have good relationships with customers as well, because, like, you know, there might be people on both sides of the fence not really being, I don't know how to describe it, but like being difficult, let's say, but that doesn't really benefit anyone. That's why it's imperative, like when you're delivering like a design or an implementation, building a relationship with the person that you're working with or for is probably the most important thing, and that I would say, because the requirements gathering never stops, and then if you do a good job, then you'll keep getting more work, and then the requirements gathering moves into the next project. Exactly, it's a continuous process. But yeah, just finger in the air, like let's say small project of 50 days, you'd probably have 10 days 10 days design, 5 to 10 days pre-build and test, let's say 15 to 20 days 15 to 20 days of like getting it on site, depending on the complexity of it and locations and logistics, getting it on site, and then obviously there's project management that comes into that as well. But we're not really talking about project management, because you'd have a project manager and you just leave them to their own devices. So hopefully that answers your question. So let me just move on to some of the other stuff. So talking about a high level design, hopefully you can see a high level design diagram with point to point links and all the rest of it. Is that clear on the screen? I think it is, yeah, cool. Right, so like in this scenario, let me explain to you very quickly what we've got, right? So we've got two data centers, if this works. Yeah, it works. Two data centers here, right? And then we've got like, so we'll work from the outside in for everything. We have 2 data centers, and then let's say we have the internet down here. Didn't work very well, bit of lag. The internet down on the bottom right, and then we have like an MPLS network in the middle. So I've got specifically L3 VPN, and that's your typical sort of MPLS network that has BGP running between the site router and the service provider, and then we have a VPLS network, which is a layer 2 VPN. So this is a sort of thing that you might see. You wouldn't just get a diagram, but there's only so much we can cover in an hour, so I'm trying to condense it, and then if we do other sessions as a follow-up, we can do a bit more of a deep dive. But this is the sort of thing you'll get from a solution architect or a network architect that's done the high-level design, and they'll probably be like, in general terms, a high-level design, in my experience, for a decent-sized project is probably around 50 pages in Word. And it covers things like, have an architectural diagram like you see on the screen. It'll give a high-level overview of the solution, but then what it'll do is it'll have sections split out. There's data center 1, there's data center 2, and then whatever aspects of the solution are being built. Some of this might already be in place, and let's just pick out the fire. I'll change the color just to differentiate. So in this scenario, it might just be, if we talk about like the project that we were talking about a wee minute ago, it might just be these firewalls which are being replaced. So when in the scenario of this diagram, but in the solution design or the high level design, the architect shouldn't just give you a picture of 2 firewalls. They really have that. Their job is to understand the wider context of the whole network of everything that is impacted, right? So if you were doing this design, these firewalls which are highlighted in green, they're relevant to all the other stuff that you see here, because you could have, if I change the color, and let's say an IPsec VPN site here. This is a site-to-site VPN wanted to talk to a VPLS site. So the traffic flow there, in this, let's say the preferred route to get to that site is going to be over this IPsec VPN, and then if the old firewall is being replaced, it comes in through the external aggregation switch and then routes like that down to the site. So you'll get a high level design, but your job might only be to do a low level design for those firewalls, or it could be those firewalls and these firewalls over here. It might be a project to refresh the firewalls in both data centers, and you have to then start thinking about, right, well, does the traffic always flow in one way, or is it split between some traffic goes on the blue line and some traffic goes via the firewall pair on the right hand side? But the solution architect, these are the types of things that they should give you some kind of indication, and then when you get into like the project implementation, it's your job to make it happen and escalate any challenges. So you might come across something in the design to say, look, how that was specified, it cannot work like that the way that you've specified it, and then it gets escalated sort of round in a circle back to the architect to say, well, if it doesn't work that way, then they would work with you to try and find a different way to deliver that. So that's one example of a high level design, is something that you might be handed over. Another one here, again, it's just really examples. So this one is kind of similar. So let's say that there was a WAN, a wide area network refresh here, and it was your job. The reason that there's so many data centers here, it's on purpose, because data centers are typically more complicated than anywhere else on the network. So let's say, for example, this site here, it was this wider architectural design in a high level design document was handed over to you, but your remit is I see a question. I'll come to that in a second. So it's your remit to replace these two WAN devices. So you see, like some people. Well, this is just like what you see here. This data center LAN. That's a really simplified. Sorry, that didn't work very well. That's a really simplified way of representing a data center. But it's probably like, it's full of load balancers, VMware, server farms, storage, all that kind of stuff. But for the purposes of the wide area network, your remit is to do the detailed design. What I've actually highlighted here and created here is, like, you might get something along the lines of this from your solution architect. So they might say, here's the high level design. If it's this might be a small classed as a small project. If there's no bespoke routing requirements, then or sorry, in this case there actually is. But if there's nothing that's like too confusing or if there's nothing that's too in depth, then they might say, here you go, here's what the network looks like, and then this green that I've just circled around, I'll make it a different colour, purple, this here that I've just highlighted, they might say, that's all we need you to do. We need you to replace this router, connect them together, make them sing and dance to the data center network down here, and then make sure that there's no routing loop that can occur like this over a point-to-point link to another data center, and that might be all that you need to do. And then in that case, when we go back to the requirements gathering, the initial requirements are right here. They've already been defined, so it's almost like a directed piece of work, that these are the objectives, this is what you need to achieve in this design, go and do it, and let me know if there's any problems, kind of thing. But when it moves into the low level design, your requirements gathering as a network, like a low level designer and a slash engineer, because a lot of the time people who are doing low level designs are actually doing the implementation too. So what your job is then to say, right, give me a new /30 network here and a /30 network here, give me a /30 network between here, and then give me a /29 if you're, like, for example, give me a /29 so I can run VRRP, and then you would say, right, well, what's my next hop into the data center, what routes need to be advertised over this way, what routes need to be advertised over that way, and the diagram's getting a bit messy, but that's where you start getting into the detail. So even though you've got requirements when this high level design is handed over, it doesn't mean the requirements gathering has stopped. And that's where in the slides when I was talking about LAN, WAN, firewalls, because the other thing, if I just work out how to, I think I can erase all link here, erase all link. Sorry, it's a little bit of lag. So one of the things just to consider is, if you have two routers that are connected, but Yeah. So if you've got these two routers, let me try down here. Yeah, if you've got these two routers, like where that says DC2 LAN, you might be handing over to a switch. It might be a Cisco Nexus running VPC, which then you have to consider like against routing being blocked over the VPC peer link and accommodating for that. Not picking on Cisco Nexus, it's just it's a well-known problem that sprang to mind. You might be handing over to firewalls, you might be handing over to load balancers, etc., etc. So there's always going to be a requirements gathering requirements that you always have to keep that gathering requirements and doing a good job and being friendly, courteous, respectful to your customer in order to make sure that you all meet the objectives that you're moving towards. So let me just close this one down to see if it helps my PC any. And that's the high level designs done and covered. What I'm going to do now, hopefully you should be able to see a low level design or a physical low level design. So while that's so some of the commercial customers don't want to disclose their data center network. They just say do Ethernet refresh or replace the firewall. Yeah, I mean that's obviously because the data centers are big bucks, right? They cost a lot of money for the equipment. I mean, like not every data center would have like a load balancer, for example. It's a great piece of kit, a global server load balancer to load balance traffic and fail over between data centers or have server farms with multiple servers and traffic going to all of them. But not everybody wants to spend or has the budget, and it's always like a trade-off, right? Where you might a priority at the time you might go into a new data center, but your priority might be to refresh the WAN because you're running on legacy 10 meg WAN links and over the MPLS, and what you actually really need is 100 meg internet, which may or may not be less expensive. So that might be the IT directors, and that might be driven by, or it will be driven by the business saying, we want to use, I don't know, we want to use a service in AWS, or we want to move all our storage into S3 buckets or whatever for a certain part of the network, and at these 50 sites, other than that, the only traffic that they're going to need potentially over the MPLS is voice. And now, like, obviously the internet has moved on these days where it, like, I work on collaboration tools, voice and video every day, and I very rarely have any challenges with it. So companies are accepting the internet a lot more now as a genuine contender. A lot of sites having like dual internet and things like that. So yeah, I'm conscious of the time because we've been talking a lot, so I just want to cover this low level design and then flick on to another one. So what we've got here, this would be, I've closed the diagram now, but if you remember the high level diagram, maybe got it on the PowerPoint. Yeah, so if you this might be zooming in on, for example, one of these sites down here, and just one of the sites, or it might be in the detailed design. You might be saying, right, so all of the layer 2 VPN, VPLS, Metro WAN sites in that section of your detailed design, they will all look like this from a physical perspective. So what we're saying here is like, I'll just use the pen color, but so if these are the WAN routers, and we see between the WAN routers, and I just kind of made this up, this isn't a real design, they always connect between each other with two 1 gig ports. They're configured in a port channel, a layer 3 port channel, and that, I've not got a port channel number, but that would always be port channel 3. Port channel 3, right? But then when you get to the WAN to LAN handover, we then start talking about, right, this, I've got gig, but we could like say, right, well, see, in line with the global LAN design policy, all WAN devices actually hand over with 2 links to a switch stack, and that's always 10 gig handover to the LAN. Hopefully that comes up. Yeah, so that might be 10 gig. And then so this is like breaking out the network into even further. And then you see here that we've got a couple other observations: gig 001, and then gig 101, and then gig 002 and gig 102. And it's so that things are like symmetric. So if you use for your uplinks on switch 1 and switch 2, you're always using gig 1 and gig 2. If you had 4 switches in the stack, you might use gig 101, gig 201, gig 301, and gig 401. So you spread the uplinks between the switch stack. And I've not drawn it in here, but it would be a similar kind of thing where you might say, if this gig, I'll just say gig 24. And then this is always gig 1024, and then this is always 2/0/24, and then that would be the same on this and on this. So you're always using, so when you send an engineer to a site, and if you've got multiple switch stacks to be deployed, then you've got a common way of deploying things, and then that leads into when you go into operations, that people know that the uplinks, if you read the design documentation, all of the uplinks for all of the layer 2 VPN sites will look something like what we've got on the screen here. So that covers physical design. Again, sorry, it's 100 miles an hour, but there's only so much we can talk about. Any questions, just put them up in the chat. And then the final thing that we're going to talk about, we can come back to any questions, is this is detailed design. Probably don't have time to go into it in mega detail, but this might be what I was talking about earlier. This might be like an edge site, which actually see a question coming in there. I'll come to that in a minute, try to answer it. So this is like, another site where we've got, you might have like, I've put WAN 1 and WAN 2. So WAN 1 might be internet and WAN 2 might be MPLS, for example. But obviously to come in via the internet, then there's going to have to be some kind of firewall capability. And it might be a dedicated firewalls. So the example that I've got here is, hopefully that draws itself in. I think if I draw a bit slower it works. So that might be like a NAT. Yeah, a NAT address to a public like on this like interface of the firewall. So it'd be like a public IP address. That's the sort of thing that you if you had 50 servers in a DMZ with public IP addresses, you wouldn't be able to put all of that into a diagram. So you might have, a table. Just going to draw a really bad table. Where you have like in your just in an Excel, and then you put it into the diagram. You put it into the detailed design document. So if this is server subnet, and then IP. So if we just say SRV1, and then 10.10.10.0, and it would be like /24 or whatever, then this might be, you might want to say, right, well, the server ranges start at 10, 11, 12, and you would list out all your servers in that table, you know, like this. But that would obviously be stored like in an IP address management platform, or, and more often than not, like a spreadsheet somewhere on a shared drive or a SharePoint site or something like that. But that's what else on this one? Let's just erase this ink. Erase all ink. Last couple of minutes, folks, and then we'll just we'll wrap it up with any more questions, and then just get feedback on the session as well to see if there's anything that we can improve. So, like the other things, I've not pictured it here, but the sort of thing that I would normally do is I'm just going to draw a squiggly line, but in Visio I would put, you know, that sort of thing. Or let me actually open up Visio and try and show you. If I go and transition to this, so here we go. Like what I was about to say was, like, I might put 192.168. Let's say 10.10.10.0/30 in there, and then put like if this was .1, I'd put .1 down here and .2 up here, and that would be how to represent like the layer 3 point to point in, you know, in a network diagram. And then as you go further down into the network, this is just a very simple network, but you might have like multiple VLANs. So this is customer LAN still from the high level design, but you might say this is VLANs 2 to 10, and then say data, and then you might add another subnet, you know, so copy and paste this, and then put that above it and move these things around, right? And the next one might be I don't know, VLANs 100 to 150 voice. I'm just completely making this up on the fly, so but that's how you would potentially start like building out your network diagram and start representing like the logical side of things. But yeah, you like there's a lot, there's quite a bit more to it, and I think it would probably take a dedicated session on building out low level design diagrams and things like that in order to cover it properly. So in regards to, let me just see if there's anything else on the slide. No, that's it really. Let me just look at the questions. We covered the one about the commercial customer. True, not really helpful. The best practice in using VSS or port channel between the top routers. So let me just get back. So if you were, my Visio is going quite slow, so let me transition to this diagram again and put it on here. Hopefully this works. I don't know. Yeah, I can't draw on this screen because it's my monitor. Right, so you're talking about between these routers and this I put clustered core switch. So yeah, so this is, what you see on the screen here is how I would typically deploy this type of design. So you would have like a single router, obviously, unless these routers had some kind of capability to be clustered. Then you're always going to have, like, if you want redundancy built in, well, you could have it two ways. You could have, if these switches are like VSS or Stackwise Virtual, it's called now in the new Cisco terminology. But if they're basically two switches, regardless of vendor, because Juniper and HP and all that all do the equivalent, and this is all part of the detailed design. So a solution architect might know that it's a HP or a Cisco switch, but they're not. They're probably doing minimal sort of. They'll look at the configs, say, right, it's configured in a cluster. But once you actually get into the detailed design, that's when you would work all this stuff out, and it really depends, right? So there's different ways to do it. The ways that you could do it are, you could either port channel. In this scenario, what you've actually got is a port channel between the router and the switch, but what you might actually have is it still being like a /30 point to point. So there's a few different options. So let me see if I can draw this without too much pain. I'll go up here. Yeah. So what you may have is a port channel with two links, but that might be one single logical link, and it might be a /30, and then that might be the same. Or yeah, you could use /31s as well if you're like short IPs. But personally, I think if you've got the capability of /30s, it's better to maybe not on a service provider network if you use public IPs and you want to preserve them. But typically, service provider understands like using /31s better than in the enterprise. If you're in the enterprise and you're handing over to the LAN, and you see like the benefit of using a /31 would be to save IPs. So, but yeah, you could get more bang for your buck with you would have more IPs that you would be able to use. That's pretty much it. So the couple of different ways that you could hand this over is you could do it as one. I don't think there's any strong benefit. I think it's just like it's much more common like to see a /30 on a point-to-point link than it is a /31. In my experience anyway. Like I don't think in an enterprise network I've ever seen a /31 used. In a data center or a core service provider network. The person that's just joined, it is recorded and it will be put on YouTube, so no worries. So yeah, the /30 basically is more understandable if you think about how you're taught about networking when you go into entry-level networking courses, and certainly I was anyway, when you're taught subnetting, and there's 256 addresses in a /C network, but 254 of them are actually usable. So you basically, how I learned subnetting back in the day is whatever the maximum number of subnets are, you subtract 2 for the network and the broadcast address. So that's kind of like being taught at the fundamental level. So if you take a /30 and there's 4 IPs and you've got 2 devices that you want to IP, I think it's more readable and understandable for maybe a junior engineer who's just starting up, or even a seasoned engineer who's just not used to using /31s. But you can use either or. And the other thing that you could potentially do here, so that could be like a slash. You could use a port channel and you could have a point to point there and a point to point there, /30 or 31, whatever you prefer. Or another, I can only talk on what I've seen over the years, but yeah, I mean everybody does things differently, and the one of the key kind of sayings in network design is it depends. So it depends on who the designer is, what approach they want to take, what the policy is, if you need to save IP addresses, etc., etc. So yeah, that's just my take on it. So the other way that you could potentially do this is you could not use port channels, and you could have 4/30s or 31s here, 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 and here, and then you could use equal cost multipath over the two ECMP just over these two links. Or the other way that you could do it is erase a link. The other way that this could be done, so physically it would look as it is, but without the port channels, and this might be, for example, a /29, and then you could have one VRRP or HSRP group, right, with the VIP of .1, and then you could have another one, a VRRP group of I'm just making these up, right, .10. So you could then have like two default routes to .1 and .10, and then that means that traffic could go that way, or it could go that way. Obviously, if there was no firewall in the picture here to avoid potential state issues. So there's three sort of main ways that you could hand it over that just spring to mind. And like when you move from like the physical handover, if you've got 4 links, you could either port channel the links and do a layer 3 port channel. You could port channel the links and do a layer 3 port channel with a slash or a point, let's just say a transit link per port channel for port channel 1 or port channel 2. You could not have port channels and still have 4 links, like 2 from each router handed over, and just use, like, let's say OSPF and do ECMP. Or you could have a shared transit network and use either a single or a multi-group or a multi HSRP or VRRP groups, and then that would, all 3 of those ways would allow you to potentially load balance the traffic across both WAN links in different ways. That said, you might only use one VRRP or HSRP group. You might only use one of them if it's an active standby service. So if all the traffic has to always go over WAN 2, and then if it's only if that fails that it goes over WAN 1, then you might only use a single VRRP or HSRP group. So I think, folks, I've talked for like an hour and 15 minutes. So we'll probably wrap it up there. I hope it was enjoyable. It's the first Twitch feed I've ever done. I've done YouTube videos, but it's the first Twitch feed I've ever done. For attending, I do really appreciate you giving me your time, and I hope you have an enjoyable evening, afternoon, morning, wherever you are. Take care, everyone. Bye bye.